This video is a brief introduction to the formatting of scientific notation, how to write numbers in scientific notation. As you can see, I've written the number 3. That would be the leading digit. Every scientific notation number must be written with a leading digit of 1 through 9, a whole number 1 through 9. So if we write 3 times 10 to the 4th, what we have then is the number 3 followed by 4 zeros. In other words, the 10 to the 4th tells us that our 3 is in the 10,000s column. So this is the number 30,000. If we add in some extra significant digits, we are knowing the number more accurately. So for example, I've written in blue 27, so the number is now 3.27 times 10 to the 4th. What this means is our number is actually known more accurately, and the 2 and the 7 replace 2 of the digits, 2 of the zeros that we had that were placeholders. So we now have the number 32,700. So the number 32,700 is written as 3.27 times 10 to the 4th, whereas the number 30,000 is written as just 3 times 10 to the 4th. So the leading digit tells you how many of the column you start in you have. So in other words, 3 10,000s, so the number 30,000. And extra significant digits written after the decimal point, if known, tell you how much more accurately you know the number. So instead of the number about 30,000, we have the number 32,700, which means somebody measured it more accurately. So to take a couple of examples, if we have the number 26,000, the 2 is in the 10,000s column, which is a 1 followed by 4 zeros. So we would write it as 2.6, because we know the 6,000s, times 10 to the 4th. What that tells us is that the 2 is in the 4th column, meaning it's in the 10,000s. So we have 20,000, and we have a little bit more because of the decimal 0.6. That 0.6 is basically telling us we have 6/10 of a 10,000, which of course is 6,000. So let's take another example. Let's look at the number 452.7. Now this is the approximately the number 400, so it's approximately 400, which means it's a 4 followed by 2 zeros. So this number turns into 4 times 10 squared, but since we know it more accurately, we write it as 4, we actually write our original number as 4.527, all digits that we know, also times 10 squared. Because it's the same size number, which our exponent tells us. So it's either 4 times 10 squared, which is approximately 400, or 4.527 times 10 squared, which is the number 452.7. Finally, just as a brief mention, a decimal, something smaller than 1, is going to be written using negative exponents because you're actually dividing by 10, because you're in the tenths or hundreds or thousandths column. So if we take the following number, 0.0034, and we look at that, this is approximately 3 1,000ths. We're in the thousandths column, which means we should be dividing by 3 tens, which means we write the number as 3 times 10 to the negative 3. And by the way, we know this number a little more accurately, so it's actually 3.4 times 10 to the 3rd. Another way to think about this in terms of getting efficient at writing this is to say, how much did I have to move the decimal over? Well, I moved it over 3 decimal places, which means I had to divide by 3 tens. So the negative 3 in the exponent is simply telling you that you're dividing by 3/10 rather than multiplying by 3/10. So I will show you how to fix some answers in scientific notation and also how to multiply and divide in scientific notation on a subsequent video.